Swayam Prabha. Digital India. Educated India.
Let me get back to the original circuit. What was the differential equation governing this in terms of this VC? By the way, I could have written the differential equation in terms of some other variable. Okay, let's say the current IC or the voltage VR and so on. What will you get in that case? Please do that. Please derive the differential equation with IC or VR as variables and compare it to what I am going to work out. By the way, the differential equation for this VC was, what was it? Okay, so that's what it was. This is the differential equation governing the circuit when it's written in terms of VC, the capacitor voltage. Now let's write the differential equation for the circuit in terms of other possible variables such as the voltage across the resistor VR or the current through the capacitor IC. Okay, so we see that VR is nothing but Vs minus Vc. Okay, so this comes from Kirchhoff's voltage law. So then from this we see that Vc is Vs minus Vr. So now differentiating both sides, what we will get is that the derivative of Vc equals the derivative of Vs minus the derivative of Vr. Okay, and substituting these two relationships into that one, we get the following: Rc times that plus dVr by dt plus Vs minus Vr equals Vs. So this, if you rearrange the terms, you will see that it is Rc times dVr by dt plus Vr equals Rc times the time derivative of Vs. Okay, and if we do know that Vs is a constant, we will get Rc times dVr by dt plus Vr equals 0. Okay, so this is, if you know that Vs is a constant. Okay, so the important thing to note is that the left hand side of that and the left hand side of that are in the same form. Okay, so the coefficient of first derivative is Rc and coefficient of Vr is 1. Okay, now we can also try it in terms of IC, and it will be similar. IC is nothing but Vs minus Vc divided by R, and if I write Vc, I see that it is Vs minus Ic times R. So time derivative of Vc is time derivative of Vs minus R time derivative of Ic. And if I substitute these two in there, what will I get? Rc times dVs by dt minus R dic by dt plus Vc, which is Vs minus Ic times R, and on the right hand side we have Vs. Okay, and if you rearrange this, we will end up with Rc dic by dt plus Ic equals C times dVs by dt. And again, if Vs is known to be a constant, we have Rc dic by dt plus Ic equals 0.
Okay.
Okay, fine. I have written all three with the variables on the left side and the source on the right side. So, what do you notice about these three differential equations? Anything or no? Left hand side is exactly the same, right? The homogeneous parts of the differential equation are the same. Okay, and this is a general property of any circuit. Now, it's not that earlier we found the solution for the capacitor voltage as Vs plus Vc of 0 minus Vs exponential minus T by Rc. Okay, now if you look at this, the left hand side is exactly the same. So, that means that the homogeneous parts of everything is the same. So, all of them, whether Vc will be something times exponential minus T by Rc, that is the homogeneous solution to Vc, and similarly Ic will also be the same way, and Vr will also be the same way. Okay. These are the natural responses or transient response or the homogeneous solution. Now, this is a general property of any circuit. Okay, and this has nothing to do with the first order differential equation either. Okay, so if you have, it turns out that for higher orders you will get combinations of exponentials. So, this just like we have one time constant here, for higher order equations you will have multiple time constants and multiple exponentials. So, the natural response of any variable in the circuit, whether it's any current or voltage, will be exactly the same. Okay, so you don't have to, if I had asked you for the current in this loop or the voltage across the resistor, you don't have to solve for the circuit again. Okay, the solution will be in exactly the same form. And also now for piecewise constant inputs, everything will also have the same form. Okay, Vc we already know. We will elaborate on this a little. Vc of 0 minus Vs. Okay, and Ic will be basically the final value, which I will write as Ic of infinity plus Ic of 0 minus Ic of infinity. This is the general form, right? The initial minus final value decaying off with a time constant Rc. Okay, and finally the Vr also will be the same. Vr of infinity, which is the final value, plus the difference between initial and final values times exponential minus T by Rc. They will all have the same time constant. Okay, so you should be able to work out the solution for any variable in the circuit, in any complicated circuit.